Hi, so in this video I wanted to show you a little library that I came across just recently that I think is actually really useful for doing quick debugging of your code. Now if you've been writing Python code for a while, then at some point I'm sure you've used print statements to help you either debug your code or maybe just understand the code flow. Now of course we do have several debugging tools at our disposal, like in PyCharm. When I'm developing that IDE, I of course use the debugger quite frequently. But sometimes it's just easier to print things out. Maybe you're inside a loop to quickly examine the values of various variables in the code as it's running without having to break and inspect the variables at each iteration of the loop. So we use print statements quite often. And then of course, before you put things in production, you have to pull the print statements out. Now the IceCream library can be very useful to essentially do the same thing, except it's more advanced, it has more advanced features, it's more flexible, and you don't have to type as much code as the print statements. Now the Jupyter Notebook is available, it's linked below in the description, and I have the link there to the library itself and how you can install it. If you're installing it for something like Jupyter, there is an extra installation step that you need to follow, which I detail in the notebook itself. It's just basically installing an extra library that we need, but we need a later version than what's actually included or in the dependencies of IceCream itself. So once you've got it installed, then we can just say from IceCream import IC. So we're going to import the IC submodule from IceCream. Now, at its simplest, we can just use IC as a replacement for the print statement. So if you have something like for I in range 5, instead of using a print I, and that should be I, instead of saying print I, you can just say ICI. And when we run this, basically it gives you the value of I, but you'll notice that it tells you what this variable was. So it actually kind of inspects what's inside here and gives you the variable itself. If we were to do something like IC 10 plus 20, you'll see this inspection here, right? It basically reproduces the expression that's in here, but in string format, and then gives you the result. Now, what's interesting about IC as well is that it passes the data back from the expression. You can see the output here was 30. We actually had that returned. So we'll come back to that and actually use that when we start adding in these kind of debug statements. Now, sometimes I've also used print statements to identify what parts of my code are running and doing something like this. I'm just going to take a silly example. I'm going to take that from the notebook. Basically, I'm just going to create two lists, one with values below a certain mean and one with values above a certain mean. Okay, so that's all this is doing. And so I get my number here as a random number between two extremes, the min and max. And then if the number is less than or equal to the mean, which is basically 150 in this particular case, then I want to essentially add it to one of my empty lists. Otherwise, I want to append it to the other empty list. And what I really want is I want to know for each number which branch I'm actually running in. Maybe it's a little bit more complex and I need to know where is my code branching, how is it branching. So by putting in the print statement, that's essentially what I get, 1, 2, 1, 2, etc. And that's great, but the problem is that you may have multiple of these print statements, 1, 2, 3, 4, 5, 6, and then at some point you realize that, oh, well, between 3 and 4, I want to add another one. Now what do? Do you renumber 4, 5, and 6 to 5, 6, 7, and then insert now a 4? Or do you maybe say print 3.1? That's what I do. Okay, it's not always easy. So what you can do with IC, instead of doing it this way, then we basically do this. So I'm just going to change this. I'm not going to print this number here. Now remember what I said, that IC will actually pass through the results of whatever expression is being passed to it. So if I do this, then IC will not only print out information about this over here, but it will also pass the result back out, and I can therefore assign it to my original num. So I didn't have to add an extra line of code here. I just basically wrapped my existing code with IC. That was all that I needed. Now for these ones, you can just use IC with no arguments, and it will basically then just tell you where it's located in the code. So this way we'll have a better indication of where things are at. And so if you see, we get this output here for the num, right? That was the random rand int. This is, it ran this function and it got a result of 149. And then after that, it ran at branch at line number 14. Now here, to see the actual line numbers, we can show line numbers. So we can see it ran here. So the number 149 was less than the mean, which is 150. It ran this branch. Yeah, that's exactly what we expect. So this is what I mean by, having something a little bit simpler than saying print 1, print 2, print 3. It just tells you which line it was at. So again, just to show you one more example with the fact that IC passes the values through, let me go ahead and write this function, myfunc a comma b, and all it does, it's just going to return a plus b, like so. Okay. So then what I'm going to do is I'm going to create a variable, called it sum underscore, and I'm really wanted just to make it myfunc 1020. Now what I want to do though is I want to basically print out some debug statement about this, that this function was called and what was the result of calling the function. Well, again, as we just saw, all I need to do is to wrap it inside IC. So if we do that, you can see we have the output from IC, and we also have the sum correctly populated with 30. All right, so we've seen that. Just want to reiterate that as well. Now, the nice thing about IC is that you can entirely enable or disable its functionality without having to rewrite any code. Unlike the print statement, I'm developing, very often I'll add in a bunch of print statements as I'm developing a function, for example. And then eventually, once I'm kind of happy with where it was, well, I remove the print statements. But then maybe, a couple days later, I come back and I realize, oh, there's still something wrong. There's something going on. I need to put my print statements back in. And of course, now it's tedious. I got to go back in and do that. So what's nice with IC is that you can actually turn off this print essentially whenever you want. So let me go ahead and show you. I'm going to take the same function that we had just to show you that it's global. It's a global setting. So where's the myfunc? There we go. So let's take this function. And what I want to do is I also want to essentially print out A and B inside this function. Well, all I need to do is just wrap it like so. Because again, IC returns whatever's inside of those parentheses. So that's got the IC as well. And now I can go ahead and say IC myfunc 1020. And so now we should get multiple things, right? We get the A and B values inside the function call and as it's being called. So in that scope, and then we get also outside of that, the fact that myfunc was called with 10 and 20, and we got the result back, right? So now what I can do is I can choose to disable IC. So if I do that, and now I call IC myfunc 1020, so I'm still calling IC here, and myfunc is still calling IC, but IC's been disabled. You'll notice that I just get the result back. Nothing else happened. So basically IC is a way that you can introduce these print statements and these kind of debugging, features without breaking your existing code. And you can disable it also without breaking your existing code. Now, before I move something into production, before I commit that for a production system, I would still remove those IC statements. I don't think they belong in production code. But as long as I'm still developing, I'll keep them around, and then all I have to do is just disable IC whenever I want to. And of course, I can re-enable IC whenever I want to. So I can intersperse disables and enables in my code as need be. So if I re-enable, and I now run this function again, then you'll see that it's gone back to being enabled. Now later I'll show you also some of the configuration options that we have to change this prefix over here, as well as to change the way it displays certain objects, right? Because you can think that IC is able to display strings and lists and dictionaries and various types of things. And as you probably guessed, it uses the representation, right, dunder method to do that. But there's a way that we can actually override that as well if we need to, and I'll show you that later. Now, I have another example that's a little bit more complicated in the notebook. I'm not going to go through it here. It's basically just implementing a merge sort algorithm and just basically adding in those IC functions to debug my code. So I start with code, I think it's correct, it's not quite correct, I add IC so I can see what's going on during this merge sort algorithm, and then I'm able to use that to debug, right, my code. And I do that both for the merge and for the recursive sort algorithms. So I'm not going to go through this here. This isn't a video on the merge sort algorithm. I just wanted to have something that was a little bit more real world, if you will. But that's in the notebook. We really don't need to cover that here. Now I will use it for some examples of IC configuration in a bit. So let me just basically copy paste those in here so you can see, so we actually have that available to call. So that's the merge step from the merge sort, and this is the sort step from the merge sort. Okay. So if we actually call sort, let's say we sort the 2, 3, 1, for example, then when we do that, you see there's various outputs. That is what allowed me to debug both of these functions and make sure that everything worked as expected. And then we still get the result 1, 2, 3. Of course, I can always disable this. Now I can disable IC. And we can go ahead and run the same thing again. Sort 3, 1, 2. And then you see now this is disabled, right? We don't have the IC enabled anymore. Okay, let's re-enable this. And the first thing that I want to show you is that I want to change that prefix, right? That IC prefix that's here. Maybe I want it to be something else for some reason or other. So if let's go back to one of the earliest examples. We do 10 plus 20. Like so, you can see we get this prefix, IC, a pipe character, and a space. Okay, that's the prefix, that's the default prefix. We can change that, and all we need to do is to go to IC, configure, output, and then we specify prefix in here. We'll say the prefix is equal to, maybe we want it to be Jupiter. Okay, like so. With a pipe and a space. Like so. So if we do that and I do IC 10 plus 20, now you can see that the custom prefix is now being used. So you can specify whatever static string you want for the prefix. But what's more interesting is that you can specify a callable for the prefix. So you no longer need to have just a static value. It just needs to be a callable function, or a callable in general, that returns a string, and that string will then get used as the prefix every time IC runs, right? So we could, for example, use the perf counter as a prefix if we wanted to. So let's do this. So from time, I'm going to import perf counter and perf counter. And then all I'm going to do is configure the output. Now I'm going to use a lambda here. Perf counter is a callable. I could call it directly, but it's not going to give me the formatting that I want exactly for the prefix, because I want to have a pipe and a space after it. And maybe, I probably don't want seconds here. Actually, it is measured in seconds. Might as well leave that. And I want this prefix debug as well. So this is actually what I want. So I ended up making a lambda. You could make a regular function, but a lambda is perfectly fine here. And I just call perf counter in my f string. So that's going to be my prefix. And that prefix, that function, is going to get called every time that we call IC, right? And every time the IC function is called, that's going to happen. So if I want to sort this list, for example, now I haven't made any code changes to the sort method or to the merge methods, right? The sort function or the merge functions. Those have stayed identical. But now you can see we get our custom output, right? We get debug and we get perf counter. Now, be careful using perf counter. You can't really use this for real timings here, because this also, of course, includes the timing of IC itself. That's calling this function, printing, formatting, printing the output, doing any kind of introspection that it needs to do to generate the text that we see here. So it slows things down quite a bit, right? So IC is not a high performance thing. It's definitely going to affect your performance. But for debugging, it's perfect. Now, of course, we can use any callable. So technically, you can even use a closure. So maybe we want a prefix that just keeps incrementing 1, 2, 3, 4, 5. I don't know why you'd want that, but maybe there's a reason for it. So let's go ahead and do that. So we're going to write a closure, and I'll include the date time in there as well. So I've got my create counter function, and it has count starting at -1. Then I create a counter function in here with a non-local count. So that's basically the free variable. I increment count, and then I print this out. And I print out the count, and I print out also the current date time, local date time, in ISO format, right? So this is essentially going to return when I create counter. So when I say counter equals create counter, when I call create counter, it's going to give me a new closure. And now I can just call counter, again and again. And you can see that the counter itself is incrementing. And of course, so is the date time. So now we can use that as the prefix for our IC. So now I can just call create counter. So I call create counter. This gives me back this function, right? This counter function that was created here, which is the closure. And now I can go back and run this over here. Same as before. Nothing's changed. But of course, now if I run this, you'll notice that I have this thing that increments. And not sure what happened here. I've not had that happen to me before. So I don't know, actually. That's interesting. Jupyter's complaining about maybe just the speed. It looks like the speed at which those messages are being published. But I guess you can set them to higher limits. Maybe my computer's running too fast. Like that's a complaint anyone has, right? Okay, so that's how you can do things with the prefix. Now there's one last customization I want to touch on, and that has to do with how IC is essentially presenting to us the data. You'll see that when it's a list, it's using that. When it's an integer, it's using that. And essentially, it's just using the internal representation of those objects. But what about when we have a custom object? Right? What happens here? Well, we need then to make sure that we provide the custom wrapper for that particular object if we want IC to use it. And I'll show you that. The example I'm going to use is actually going to be to work with JSON. So let's say that I have some JSON data, and I'll copy paste it. So this is my JSON data, right? It's just a string. Now, if I do IC of JSON data, well, it's going to take the representation for a string. It's going to give me a string representation. As you can see, that's not very pretty. I mean, it's workable, but, right, because this is the representation of that string. If we don't actually, honor the escape, if we don't actually print the escape characters. So if we do, this is what it looks like, right? And so that's not very readable. And for that matter, neither is that. So how to go about solving that problem? Well, one very easy way when I'm using a print statement is to do the following. I'm just going to copy paste it. So I would import the JSON module. The first thing I do is I take my JSON string, load it up, so it'll become now a Python dictionary, and then I turn around and dump it back to JSON, but here I specify the indent. And so when I do that, I get a much better formatted output. So all what I need to do is basically create a custom type that's going to have this particular representation. That's very simple to do. We're going to have a class JSON. Now, I'm going to inherit from string because it is a string, right? And the only thing that I want to be different is the actual wrapper. So I'm going to override the wrapper. And what am I going to override it with? Well, this right here, right? So I'm going to return, and then it's not JSON data, but self. right? This is the string itself. So that's all we need to do. So now I can just say JSON data. That should give me my custom representation, and indeed it does. And in fact, now if you do JSON data, well, since IC is using the built-in wrapper of this class, well, it's going to use the same thing. And as you can see, we get a nice representation over here. However, what if I don't want the representation here to be the same as the representation here? Here, for my actual representation, I may want it to be as compact as possible. So if I want it to be as compact as possible, here's what I would do in the JSON class. I would go here and I would not set my indent. And instead, what I'm going to do is I'm going to set the separators. So I'll set indent to none. I don't want to set anything there. And separators, I need to specify a tuple that is going to contain the comma separated definition and the colon separated definition. Well, I'm just going to use a comma, and then I'm going to use a colon, right? Now, the default is to say comma space and colon space. That's the default if you don't specify your separators. Here, I'm trying to make it as compact as possible. No indentation, the separators as compact as possible. So now, if I look at the representation for JSON data, of course, now you'll see it is as compact as possible. So that's good. That's what I want. But when I'm doing my IC, right, and I'm inspecting, let's say, this object, then I don't want that compact representation. That's not what I want here. I want the more verbose one. Now, the way that IC works is that it uses single dispatching. And if you don't know what that is, I do cover single dispatching in some detail in my Python deep dive course on Udemy in part 1. And basically, the way that IC does it is you register a type with a function. So you say, okay, for this data type, I want you to use this function to do the representation. In this case, we do have a new data type called JSON. So all we need to do is to tell IC that for a JSON type object, we want you to use this function for the representation. And that's very easy to do. We have to say from IceCream, we need to import the argument toString. And all we need to do is and this is a decorator, so we need to take this, and we are now going to use the register method or function, and we're going to register a data type. This is where the single dispatching comes through. Essentially, that's what IC does behind the scene. It's just a single argument dispatch. And then we just have to create a function. You can name it whatever you want. Some people even use an underscore to indicate we don't care. I do care, not because the code cares, but because I like to, know what this is doing. So it's going to receive the JSON string, right? It's going to receive the JSON object because we're registering for JSON. So it's going to get past this JSON object, which is just a string, right? So that's why I called it JSON underscore string. And then all we need to do is just to basically do the same trick we did before now. So we'll dump, and then we'll say JSON.load. And we're going to take the string itself, which is the JSON string, like so. And then we'll do the output with an indent of 2. And that's it. That's all we need to do. So now we've registered this function here, JSON pretty print, so that IC will use it whenever it encounters an object of type JSON. And so if we do IC JSON data, then you'll see that it uses now our verbose output, whereas the default representation of a JSON object is still the compact version that we see over here. So there you go. This is the IC library. It can really be quite handy at times. I've only just started recently using it, but I think I'm going to keep using it. It certainly, has a lot less printing, less code involved. I can also turn it off and on however I want while I'm developing the code without having to remove all my debug statements. So I really like that as well. And it's pretty versatile. So there you go. See if you find it useful in your own development as well. Thanks for watching.